Good evening, students. Today we are going to learn about the topic atomic mass unit. What is AMU and what is this atomic mass? That we will start. And for expressing this atomic mass, we need the special unit called atomic mass unit. Before going to that, we will discuss about the representation of an element, how the elements are represented in symbol form. So a student, regarding representation of element or symbol of an atom, so after the discovery of laws of chemical combination, different scientists started representing the chemical reaction in different ways. They started thinking to represent this chemical reaction in simplest form or with a simple representation. For that, they need first the elements to be represented by some symbol or some alphabets. So for that, the very first, Daltons had given different symbols for different elements. So that we are going to start. So students, representation of, so right, representation of an element in symbol form. So very first, it was Dalton. So Dalton, the same Dalton who has given the atomic theory, Dalton's atomic theory. So it was Dalton given the first representation of the known elements at that time, given symbols for known elements. Means at that time, what were the elements known? For that, he had given this symbol. A student, keep in mind, today we are knowing that there are nearly 120 elements. But at the time of Dalton, means just beginning of 19th century, the number of element was not this much. It was just nearly 50 or 60. So he was trying to give the 50 or 60 symbol for that. So the symbol that Daltons had given was not in term of alphabet, but with some simple figure. So that symbol are not used today. So today, what we are using is a different kind of symbol which is given by the UPSC conference. That symbol is different from the symbol given by Dalton. So it is just, we have to understand how these symbols were developed or how conveniently this symbol was taken. So very first, it was the Dalton given the, so Dalton given symbol for known element at first time. So first time for representing the element, Daltons have given different symbols. So he told that an element should be represented by its atom. And for that atom, we must use symbol rather than writing the big name. He proposed certain symbols. So what are those symbols? Those things we are going to learn. Students, the symbol will represent that particular element, but how much atoms of that element? It will be only one atom of that element. It simply means that. So a student, what Dalton's proposed for the known element like hydrogen. So how was the representation? That let me represent. So the element taken and the symbol for that I am writing. The element hydrogen was represented by a circle, and at the center of that circle a dot or thick dot. So this was the representation of hydrogen. So this was the symbol given by Dalton. So it was according to Dalton's atomic theory or Dalton's symbol. But nowadays we are not using this, we are using something different. So this symbol is as per Dalton. But nowadays we are denoting this hydrogen by H only. So this is what? Modern representation. So this representation or nowadays representation was given by IUPAC. IUPAC is a body or a meeting which decides the internationally acceptable things. So what are the internationally acceptable things? Those things are decided here. The full form of this IUPAC is International Union of Pure and Applied Chemistry. So it is the general body or a meeting or a conference of the big scientists and chemists who decides the nomenclature of different compounds and elements. Many other functions are also there. So nowadays we are denoting it by H. Second, if we take the carbon, I am just taking the few. Carbon. As per Dalton, the symbol for carbon was so a circle, and that circle was colored. So that circle was shaded. So this shading was, means this would be shaded. How I shall say it? Even different color was considered. So it was shaded like this. See, it was completely filled or shaded one. Even different colors was given for different shading, and different color represent different element. It was that one also. So students, here we are observing that representation of element given by Dalton's was not convenient. Therefore, in modern day, this carbon is denoted by the simple C. Let me take one more. Say oxygen. Third one is oxygen. Oxygen was also denoted by a circle but without shading. Nowadays, This oxygen is denoted by O. Let me take one more. Say iron. Iron was represented by Dalton by putting I inside the circle or a small circle. So here we are observing, even for remembering this symbol given by Dalton is not convenient. So nowadays it is simply denoted by Fe. Why Fe? Why not I? That we will discuss later. Because the Latin name of iron is ferrum. So ferrum may start with F. So Fe is taken.
Sir,
Yes.
sir, for oxygen it is O2, no?
That is the molecule. I am talking for the element have to be represented by its atom. So atom is represented by only one, not the two. If you are writing, say O2, O2 is what? It is the molecule where two atoms are joined. Okay? So it is not the O2, but the symbol for representing oxygen is O. Though two oxygen atom combines together to form O2, and this O2 exists freely in atmosphere, okay, or freely in nature. So O2 is a molecule, not the atom. For representing an element, one atom is considered, and the atom is what? O. Now let us go for some other symbol. Say for the copper, for copper, he had taken inside this circle a thick C should be written. So this way he have given different symbol. Nowadays it is denoted by Cu. Why Cu? Again the Latin name is cuprum. So that UPSC nomenclature and their rule we will also discuss. Let us write few more. So the sixth is our lead. The lead is denoted by circle, and inside this circle L have to be written. Nowadays it is denoted by P with B. Why PB? The Latin name of lead is plumbum, so it is denoted as PB. Let us write few more. The seventh one, take the silver. He had given the symbol inside this circle, write S. Nowadays it is denoted by Az. Az Latin name, based on their Argentium, the Latin name. In similar fashion he had given different symbol. Say for gold also, for phosphorus also, the eighth. Let us write some difficult symbol given by Dalton. Say for sulfur. For sulfur he has given the symbol. See here he cannot use the S. S was used for the silver. So he had given this circle. Inside this circle one shall write this plus symbol. It is representing this. But nowadays this sulfur is denoted by S. Similarly many other symbols were given. Even if you consider the phosphorus, let me write few more. The ninth, the phosphorus, the symbol given was this circle, and in this circle inverted Y have to be written. Means it should be divided into three parts, this circle. Here we are observing it is difficult to remember this symbol of phosphorus. Nowadays, for simplicity, it is denoted by only P. So this was all about, even there were other one. So let me put one more. Mercury. Mercury, the symbol given was, inside this circle, you have to put a small teeth or like this. So these were the denotations given by. But nowadays, this mercury is denoted by H than G. HG based on their Latin name, this denotation is given. So many more are there. If we consider the gold, for gold, the symbol given was, inside this, first these dots have to be drawn at their end, and in center G have to be written. Nowadays it is denoted by AU, Latin name Oreo. So here we are observing that the different symbols given by Dalton was difficult to remember. So therefore it is not used today, and now the simplified symbols based on their alphabet is taken. Getting a student? But what is the importance of Dalton's symbol? It was the first attempt by the Daltons to represent the element by symbol. Okay? So right. So importance. The importance was, he proposed or attempted or first attempted to represent element by symbols. Elements in symbol form. So rather than writing the big name, if the symbol is given, then that will represent that element. Okay? And for symbol, one atom was considered, not their molecule. But what was the drawback and limitations? The limitation or the bigger challenge was to keep the symbol in mind. Means it was difficult to remember the symbol itself. If we consider, say, for phosphorus, here are you getting? It is difficult to remember this symbol. And say mercury, are we getting? Like this. So it was difficult to remember. So it was, or it is, difficult to remember. Remember this symbol and draw. Both. Means it is not convenient. That is not convenient. Convenient to write these symbols. Therefore, considering the convenience, other scientists start thinking to represent this element in simple form. So therefore, alternative symbols was given by UPSC. Therefore, simplified symbol based on the alphabet alphabets, alphabet or alphabets, maybe the only one, means the starting alphabet of element. So simplified symbol based on the alphabet of name or their Latin name, of element was proposed later by UPSC. A student. So therefore, Dalton's symbol are not relevant. Why not relevant or not used? It is difficult to remember. Therefore, Dalton's symbols are not relevant or not in use. Are we getting? So today we are not using the Dalton's. Why? Because it is difficult to remember. What is this IUPAC? A student, this IUPAC is very important entity or organization which is making the nomenclature, symbolic representation convenient. Many other things also. The full form of this IUPAC is International Union of Pure and Applied Chemistry. This is the full form. A student, here I stands for international, U stands for union, P means pure, A applied, and C chemistry. Okay, so it is what this IUPAC is. It is an entity or organization. So just write one line. Organization, sometimes also called as agency, which makes a study of chemistry convenient, and not only convenient and internationally acceptable. So whatever these symbols we are learning, it is not given by India or not only accepted in India, but it is acceptable everywhere in all the countries. So IUPAC makes the study of chemistry convenient and internationally acceptable. It is this one. So it gives symbol for element, Not only element, considering this element, their molecular formation also defined, molecules, name of the compounds, name of compounds. This we will learn in class 10, that remembering the organic compound name is quite difficult because there are millions of organic compounds. So general rule for nomenclature or giving the name is proposed by UPSC, and based on that the name of any compound can be given very easily, or if the name is given, its structure can be drawn very easily. So these are the function. It is not only this much, it have also given your AMU, atomic mass unit. Okay, so it had defined, so it has defined many quantities in chemistry, quantities in chemistry, or in science rather we can write, like AMU. So what is the definition of AMU? It was given by UPSC. Okay, so who had given the name AMU or definition of AMU? Basically it is UPSC. Who had given the name of the various compounds like organic compounds, symbol for these elements and compound or their molecule? It is UPSC. So UPSC, that kind of agency. So what is full form of UPSC? That you need to keep in mind, students. It is this one. So how the symbols are given? What are the rules for denoting the element by symbols? So right, the naming of element or symbols, or write rule for representing, rules for representing an element or different elements by or in symbol form. So this is given by or proposed by whom? By UPSC. Okay, UPSC. If anyone is asking who was the exact person who has given this symbol, later on it was accepted by UPSC. So it was Berzelius. So the person involved, or it was basically proposed or suggested, you may write, to represent the element by considering their symbol by the person named Berzelius. It was this person. Okay, so what are the rules? So according to this UPSC or Berzelius, the different rules, the very first rule was elements should be represented by few alphabets of their name. It was the very first one. Okay, he also specified element should be represented by its atom. So element is represented or should be represented by its one atom. Means whether you denote the atom of that element or that element itself, both mean the same, not the molecule. Write in bracket, not the molecule. Example, say oxygen. If we want to represent the oxygen, then the alphabet from the name should be taken and just only one atom should be taken. So it is O as one atom. This is correct way. Not as O2. Okay? So O2 is not representation of oxygen. What O2 represents? A student, since O exists as O2, not as single O in free state. Therefore, in reaction only. So in reaction, it is not the atom, but how the substance exists. So the substance exists as molecule. So in reaction, the state of existence, the existing means how the substance exists or appear in this nature, the existing molecule is taken. So do not get confused that O2 is the symbol for oxygen. No, symbol for oxygen is O. If you are denoting O2, means it is representing two atoms. Getting now?
Molecule.
Yes, so O2 is a molecule. Okay, so O2 as one molecule, but it represents how much atom? Two atoms.
Two atoms.
Good.
Two atoms.
Yes. So a student, denotation for oxygen is O, not as O2. That is one thing. So it was that proposition. So element should be represented by its atom or by its one of the atom only. It was this one. Then coming to the next proposition or next rule was the name should be given or name should start or the symbol for an element should start with the alphabet of that element. Okay, or the Latin name of that element. So right, the first letter of the symbol of a symbol is always written in capital, is always written in capital. It is one thing. And following that, and after that, other letter should be a smaller or in lower caps. Okay, means it is our lower case. It is this one. So example, if we are writing say aluminium, if we are considering aluminium, then the symbol must start with A.
AL.
With this A, there could be the other element. So to differentiate it from the other, one more symbol or one more alphabet or letter is taken. So L is taken. So it is this L should be in a small. Why? From A there could be the argon. Okay. So this also start with A. Then how to differentiate with aluminium? Another small R is taken. Okay. It is like this. Then the third rule was that so the symbol should be written by the first alphabet of their name or their Latin name. Getting? With the first name, if with the same alphabet more than one elements are there, then succeeding to that letter, other letter or alphabet should also be taken. Okay. So symbol of some elements are formed from the first letter of name and letter appears in the name. Okay. So write name of element or write of an element must start with the first letter of the name, or it may be their Latin name, or because Latin means the German, or Latin name means the name proposed or given by the German. So it symbol of an element must start with first letter of their name or Latin name. If Latin name is there, then this Latin name is preferred because Germany have done a lot of research over this. So to keep their hegemony or to just keep their remembrance, it was accepted that yes, Latin name should be preferred. So it is preferred. So for an element, there may be more than one name. One is proposed by Latin, means German, other by the other countries. So if Latin name is there, symbol starts with the Latin name. What they are? So that we will write. But before that, what is the rule? Let us understand this better. So symbol of element must start with the first letter. But it may be possible that more than one element start with the same alphabet or same letter, then more than one letter should be taken in their symbol. So must start with the first letter of their name and followed means also contain by other letter. So other letter should be in a small, followed by other letter for the elements which is having name starting with the same alphabet, followed by other letters if required. when it is required, if more than one element start with the same alphabet. Example, say hydrogen and helium. Here we are getting that both hydrogen and helium starts with H. Then how to differentiate these two in their symbol form? Then it was proposed that for hydrogen you just take the H, but for helium you need to append another alphabet of the same element, means the E, He is taken. Okay? So it is this one. So these were the proposition. But if there is some other element which have Latin name, then the Latin name is preferred. Say, if we consider the sodium. So sodium is the other element, but for the sodium, the Latin name is natrium. So natrium is what? Latin name of sodium. So it is Latin name of sodium. So the symbol for the sodium is taken by considering the two letters of their Latin name. So it is denoted by N and A. Are you getting? Not as S or SO. Are you getting, students? So considering this, we are going to write the various names and various symbols. So this way, a unique symbol was proposed for each element. Means none of the two elements have the same symbol. So write unique symbols unique means the different symbols are given. Or unique symbol has been given. Let us write frame like this. Has been given by applying above rule. By applying above rule. So how is this? What are the unique symbols? Those things we are going to understand in more detail. Students, here we have to keep in mind what is about the symbol that we are going to write here. Everything you have to keep in mind. You have to mug up these things, because these are very useful. This will be used again and again throughout the chemistry. So we have to keep in mind all these things. So never forget, though there are total 120 elements, corresponding to that there are 120 symbols, but at your standard all those 120 are not important. Only 25 to 30 are important for you. So what those are, that I'm going to write. A student, so let me write for the element and what is their symbol used. and some remark. Means if the symbol is varying than their Latin name. If it is varying. Okay. So many a time Latin name is also asked. So very first you have to keep in mind the simplest or the very first element is our hydrogen. It is denoted by H. Okay. No Latin name or Latin name also as the hydrogen. The second one is our helium. The symbol is He. So for hydrogen, this H is taken, and for helium, H as well as E is taken. So the symbol always start with the capital one that we are getting, followed by the smaller one. Next, the third element is our lithium, denoted by L and I. The fourth is beryllium. So a complete list is there. Let me just search. What are the complete list that you need to keep in mind? Because those things are asked again and again. So that's why I want to give you the complete list, what you need to keep in mind. Yes, student? Yeah. Up to nearly 20 you have to keep in mind. So right, for the beryllium, Be is taken. Here we are getting Be, it is Y, student. LL, here it is the double L. Beryllium. You have to keep this name as well as their symbol in your mind. The fifth one is our boron. The symbol for this is B. The sixth one is our carbon. The symbol for this is C. The seventh one, nitrogen. The symbol for nitrogen is N. The eighth one, oxygen. The symbol for oxygen is O. The ninth one, fluorine. FLU, fluorine. Many times we are reading FLO. So the symbol for this fluorine is F. The 10th one is our neon. Symbol is Ne. The 11th one, sodium. The symbol is different than this S or SO. It is denoted as Na because its Latin name is natrium. I will write the Latin name whatever required. The 11th, after this 11th, the 12th one is our magnesium. The symbol is M and G, not MA. Here we are getting G, which is just after one alphabet. The 13th one, aluminium. The symbol for aluminium is A, followed by L. The 14th one, silicon. The symbol is S, I. 15th one is phosphorus. The symbol is P. The 16th one, sulfur. The symbol is S. Here we are getting Si was for the silicon, but S is for the sulfur. Then chlorine. Let us go in next page. 17th one is our chlorine. Symbol is C. With the C, one L is there. C and L. The 18th one is argon. A and R. The 19th one, potassium. So potassium is denoted by a different symbol called K. Why? Because the Latin name is kalium. Okay? Like natrium, it is kalium. The 20th one, calcium. It is denoted by C and A. Calcium. There are many more. Means continuously you can write up to 120, but a student, I have written in serial fashion. Means what is the order? So this order number is also important. This we will learn in next chapter called atomic number. So it gives the atomic number. How is their mass? If you are knowing this serial number, their mass you can also predict. So nearly it is the double one, but not exactly, slightly greater than the double one. So those things we will learn in next chapter, but in this chapter we need to keep in mind what are the symbols given, how these symbols are. Those things are important here. A student, after this much serial number, randomly some other elements we have to keep in mind. So those elements are most common. So what are their symbol? We have to write them. A student, right here, few more. All this you have to keep in mind. You have to by heart this. Not as 21, so you can leave it. Leave this serial order. I am just writing. Or we may keep this serial order also. That doesn't affect much. The next one is our barium. This is quite useful in our next class. I mean in class 10th. The symbol for barium is Ba. We have written earlier beryllium. Okay, it is barium. That we have to keep in mind. Like chlorine, there is another one called bromine. Another useful symbol. So it is denoted by B. After that there is R. Br. The next one is cobalt. Or let us write the copper. The symbol for copper is C. After this there is U. Not as CO, based on their Latin name, cuprum. Then there is cobalt, denoted by C and O. It is this one. Then we have to keep in mind for the iron. Iron denoted by F and E, their Latin name we need to keep in mind. It is our ferrum. So based on this, their Latin name, iron Fe is used. Gold denoted by Au, based on their Latin name, Aureum. Another, lead denoted by Pb, based on their Latin name, plumbum. Then one more, zinc. Zinc oxide and zinc chloride, these are, and zinc sulfate, these are very useful. So zinc, the symbol is Zn, considering the Z and N. Another important one is our uranium. So this uranium is a radioactive element used in nuclear reactor, denoted by U. Okay, so student, whatever these symbols we have written, these are very important, and this we need to keep in mind. Let me write one more. Mercury, denoted by Hg. So this Hg is based on their Latin name called hydrazium. So right, hydrazium. Sorry. Student, these are the important that we have to keep in mind. Here, Latin name for mercury is important, or all the Latin name are important to just keep in mind what is this symbol. So H and G is taken from the mercury. The other one, like our lead, called plumbum. Gold, Aureum. So this lead and gold are other important. Iron, ferrum. It is Ferr. It is double R. Okay, now student. Ferrum. It is ferrum. This much is enough. Sodium and potassium we had also written. Potassium is our chylium, K. Then coming back, there was one more called sodium, the Latin name. Na was taken from their natrium. Na is taken. It is R. It is U. So this is natrium. So these are the Latin name based on which the symbols are given. So student, what are the element or important element rather for you, and what is their symbols? This you have to keep in mind. Okay, student. Now we have to go, or now we have to understand, after these symbols, how these elements are differing from other. What are the characteristics? The characteristics are their masses. The mass of hydrogen is different from mass of helium, mass of lithium. We will learn in next chapter in more detail. The more important property is their atomic number or their serial number. So whatever in left hand side I have written as the serial number, this serial number is basically their atomic number. So this atomic number up to 20 I have written, those you have to keep in mind. From this you can compare that hydrogen is the lightest element. If you consider the mass is only 1 AMU, whose mass is 1 AMU. So what is this AMU, that we can understand later, but if we are expressing this mass in term of gram, then we can say hydrogen is just 1 gram. A student, there is a large difference between this gram and this AMU. This gram will represent large number of atoms. How many atoms? That you will see that this 1 gram of that element will represent 6.022 into 10 to the power 23 atoms. If this much atoms of a particular element is taken, then that mass will be in gram. This we will learn later, or we will understand in the same chapter, but after 1 or 2 topics. A student, so therefore the next important property is the atomic mass. We can observe that atomic mass of helium is 4 AMU. Means if you are taking 1 atom, so 1 AMU means for 1 atom the mass is 1 AMU. But if you are taking 6.022 into 10 to the power 23 atom, then its mass will be in gram. Similarly, if you are considering the helium, then mass of 1 atom will be 4 AMU. But means of 1 atom of helium. But if you are taking 6.022 into 10 to the power 23 atoms of helium, then its mass will be the same 4, but the unit will change at the gram. It means for representing in gram, we have to consider the multiplication factor 6.022 into 10 to the power 23. So how is this? This we will also understand. But here you have to keep in mind here itself that if you are considering 1 atom, the units should be in AMU. Means for 1 atom, the unit is AMU. But if you are taking 6.022 into 10 to the power 23 atom, then the unit should be in gram. Okay, this we have to keep in mind. A student, later on we will also learn in more detail that this 6.022 into 10 to the power 23 is given a special name called as Avogadro number. Like, how is this? Student, you can understand, like if we are taking 12 is called, what is this 12 or collection of 12 particle is called how much?
Dozen.
Very good. So dozens. In the similar fashion means it is 12 collection of 12 pen means I have 1 dozen. Similarly, collection of 6.022 into 10 to the power 23. This number is called Avogadro number. Okay. Later on this we will learn that it is also called as 1 mole. This we will learn in the topic mole concept. Okay, student? So this much number. So this 6.022 into 10 to the power 23 is a magical number which converts the AMU into gram. Means AMU means 1 atom, but if Avogadro number of atom or 6.022 into 10 to the power 23 atoms are taken, then it mass become in gram. Are you getting? Means what? For just having a difference of 1 gram or if you have a watt of or measuring device of 1 gram, then for getting the deflection of 1 gram you need to put 6.022 into 10 to the power 23 atoms on the other side of the balance. Okay, student? So that will deflect in gram. But if you are taking 1 atom only, its mass will be very, very small. How much small? 1 divided by 6.022 into 10 to the power 23. That much. So what all these are? This we will learn in the topic called atomic mass. So let us write what is atomic mass and what are the units. Students, so write atomic mass and its unit. So the unit, if we are taking for 1 atom, it is called as AMU. Okay. And if we have Avogadro number of atom, means AV. Avogadro number that I was explaining earlier. Avogadro number, or we may write the complete one, 6.022 into 10 to the power 23 atoms, then the unit shall be expressed in gram. Okay, these are the two we are using. So if 1 atom of particular element is taken, then it will have the unit in or mass in AMU. Say for hydrogen, if we are taking example, if we are considering the hydrogen, then 1 atom of hydrogen, its mass will be 1 AMU. Sometimes in short it is also denoted as only 1 U. But if you are taking 6.022 into 10 to the power 23 atoms of the same hydrogen, then the mass of this much atom will be 1 gram. Are you getting? If you are taking the helium, then you can observe that, or you can find that if you are just taking 1 atom of helium, its mass will be 4 AMU or simply 4U. It will be denoted like this. But if you are taking 6.022 into 10 to the power 23 atoms of helium, then what will be its mass? Can you tell? Yes, student, tell me. Mass of this much atom will be nothing but the same 4, but here you have to use the unit gram.
4 gram.
Yes, it will be the 4 gram. The same is true for all the other elements. If we are taking, say, sodium, then it is found that this sodium is 23 times heavier than hydrogen. So, if the sodium is taken, so one atom of sodium, sodium denoted by Na, then its mass will be 23 U or 23 AMU. Okay, student? AMU or U mean the same thing. But if you are taking 6.022 into 10 to the power 23 atoms of sodium, then its mass will be how much, student? Can anyone tell me? Yes, 23 gram only. Okay,
23
the
gram.
only unit is replaced. Okay, let me take one more for your understanding. If we are considering the carbon, then it is found that this carbon is 12 times heavier than the hydrogen. So if we are taking one atom of carbon, what will be its mass? So it is 12 times heavier. It is 12 times heavier than hydrogen. Therefore, its mass will be 12 U.
12, 12 AMU.
Good. So 12 AMU is for how much atoms, student? For one atom of carbon. But if we are taking the Avogadro number of atom, means 6.22 into 10 to the power 23. It is called as AV, Avogadro number of C. Then what will be its mass?
12 gram.
Its mass is 12 gram. A student, here we have observed sodium is 23 times heavier than hydrogen. Therefore, it was 23. So, student, what we are observing that these mass are nearly unique or different for different elements, though we will learn later. If there is isobar, they may have the same mass. That we will learn later. So here we are observing that different elements have different mass. Therefore, this mass of one atom is called as atomic mass. So this is your atomic mass of which element? Hydrogen, student. Okay. If you are taking Avogadro number, so it is expressed in gram, so it is called as gram atomic mass. Gram atomic mass of hydrogen. So student, here we are observing whether I am speaking gram atomic mass or atomic mass. The number remains the same, only the unit get changes. And this much 6.022 into 23 is called as Avogadro number, and this is also called as 1 mole of that. Like dozen, which is 12, 1 mole is this much number. So sometimes it is also called as molar. So taking this mole, it is also called as molar mass of hydrogen. So student, these three terms like our atomic mass, expressed in U or AMU. This gram atomic mass means the same thing, but unit become gram, and it is a representation of Avogadro number, or 6.022 into 10 to the power 23 atoms. So it's called as the gram atomic mass. This number is also called as mole or 1 mole. So it is also means this gram atomic mass is same as their molar mass. Okay, student. So this gram atomic mass and molar mass, they are same quantity, and it is coming from the Avogadro number of that atom. Okay, student. Here we are observing the other element like helium. It is, this helium is nothing but it is simply 4 times heavier than hydrogen, or it is simply 4 times heavier than 1 AMU. It simply means this. So what is this AMU that we are going to learn today? A student, atoms are so small that it is difficult to measure the mass of one atom by placing on one of the plane balance. Therefore, initially, measurement of this mass was taken the relative one, and it was determined by considering the reaction. Okay, means how much hydrogen is combining with how much water, considering that the mass was given. So initially the mass was given in gram, but it was later on found that this gram means the gram molecular mass contain Avogadro number of atoms. So the mass of one atom was determined and it was expressed in AMU. So write that point also. So students, similarly, there will be the mass for each element. Get it? Means different atomic mass for different element. Nearly different. So student, atoms are very, very small. Even it is not visible to our naked eyes. Therefore, it cannot be placed on any balance and measure its mass. Very, very small. So, its exact mass cannot be measured. Measured by any balance, means the plane balance used for measuring the other quantity or measuring the mass of any other substance like vegetable. We can take sufficient amount of vegetable, we can place it on one side of pan and 1 kg on other side, we can measure. Similarly, this taking one atom itself was very difficult. Then how to place it? Because one atom cannot be seen. So therefore, this chemical reaction or laws of chemical combination. So reaction was used its relative, means one is heavier than other by how much amount. So reaction was used to determine its relative mass, which was initially given in gram. Means say 12 gram of carbon was taken and the 32 gram of oxygen was taken. Then it was observed that all the carbon get reacted and we were getting 44 gram of carbon dioxide. Okay. So this mass was initially determined by the reaction, and the mass determined was in gram with respect to other atom or other element. What do we mean by this? Let us understand. So initially what was observed? So just measuring the mass of one carbon is impossible. So the certain amount of carbon was taken for the experiment in laboratory. Certain amount of oxygen was taken in the laboratory. Then it was found that this carbon have reacted with oxygen, means all the carbon get burned. Oxygen later on denoted by O2. So for reaction we are using the term O2 rather than O. Carbon dioxide, CO2. It was observed that if we are taking, or during the experiment 12 gram of carbon was taken, then with this 12 gram of carbon 32 gram of oxygen was used. This way it was observed that 12 gram of carbon needs 32 gram of oxygen, simply like that. But oxygen was found to be in molecular form. So if we consider this in atomic form, it means O2 needs 32 gram, that is 2 oxygen atom needs 32 gram. So one oxygen atom will need how much?
64.
64. Means 2 oxygen atom need 32 gram, then 1 oxygen atom will need how much, student?
16.
So 12 by 2, yes, it is 16 gram. Okay. So this way, how much oxygen or what is the mass of the oxygen atom, it was stated. It was also found later on, if one considering the hydrogen, say hydrogen is taken and oxygen is taken, it has formed the water. Then during the experiment it was determined that the balancing is first done. So 4 gram of hydrogen is reacting with 32 gram of oxygen to give you 36 gram of water. Sorry, student, it is like this. It is not 4, but it is our 2. So correct it. So H2, the 2, so total 4 is there. So we need to put the suffix 2 here. So it was found that it is our 2 gram. Hydrogen is 1, but total 4. So it is 4 gram. Because the 4 plus 36, 2 is giving us the 36. That way we can also verify. So it was found that this hydrogen, which is 4 atom here. So 4 atom of hydrogen or 4 gram of hydrogen was required. So considering this 4 means total this suffix 2 at 2 as the 4. So this was expressed as 4 gram. Then if this was 1 atom, it is basically not the gram. Later on it was discovered the correct term used for this gram is your AMU. So later on, with later discovery, this G was replaced by U. So for 1 atom, it was 1 U. Similarly, for the oxygen, O2, the same thing can also be observed here. Means for 2 atom, it is 32. So it is our 2 atom. So for 1 atom of O, it will be 32 by 2.
Divided by 2.
16.
16.
Later on, this G was replaced by U. But initially, it was taken in term of G because measuring U was very difficult. So what is this atomic mass? Let us define that. So atomic mass, it is mass of an atom of a given which tells how much heavier than the unit used. So the unit used was your AMU. For 1 atom if we are considering. Yes. So it was, so how many time AMU is there? So what is this AMU that we need to define? So student, define this AMU, atomic mass unit. Atomic mass unit. So atomic mass unit denoted by AMU. But later on, rather than writing this bigger AMU, it was suggested to use the term U only in place of AMU. Okay, student? So now in short, it is denoted as U, and this U is simply called as your unified mass. Means same one atom is showing how much mass, it is that one. So also called as unified mass. Student, let us define this AMU. What is this AMU? Student, this AMU have different definitions. Initially, this was defined in the term of oxygen. Why? Because oxygen was most reactive, that was able to react with all the other elements and give the reaction, and by that reaction, this unit was, or this mass was determined. So initially, it was defined in term of oxygen, but nowadays it is defined in term of carbon. So right, initially AMU was defined in term of oxygen as 1 AMU is equals to 1 by 16th the mass of an atom of oxygen. So this was the initial definition. Why? Because yes, oxygen is able to react with all the other elements, and this mass was determined by the chemical reaction. So oxygen is able to react with most of element. A student, this was also for hydrogen, because hydrogen is also able to react with all the element. So for hydrogen, in term of hydrogen, 1 AMU was same as the mass of one atom of hydrogen. It was the initial one. So this much was the initially how this AMU was developed. But now, finally, if you have to define the AMU, then you have to write this one. Nowadays, AMU is defined as AMU, or simply U is defined how? In term of carbon, not the oxygen. In term of carbon, considering the mass of carbon as exactly 12. So considering mass of carbon, means atomic mass of carbon as exactly 12. So mass of carbon is exactly 12 AMU. So therefore, nowadays this AMU is defined like this. So what is the definition? The definition is like this. 1 AMU, so right, 1 AMU, full form you can understand, atomic mass unit, is a mass unit equal to, or exactly equal to, exactly 1/12. This we have to keep in mind. 1/12 means 1/12. It simply means that is 1/12. Keep in like this. That is 1/12. So 1/12 the mass of one atom of carbon. A student, this is. So what is this AMU? So student, write this. 1 AMU is equals to 1/12 mass of an atom of carbon. Okay, student. So one atom we need to consider. So this is the definition that you must keep in mind and write this way one. So 1 AMU is 1/12 mass of an atom of carbon. So means 1/12 mass of an atom of carbon will be denoted by U. It simply means that. So 1/12 mass of carbon, that will be denoted by U or AMU. It simply means that. Now we are knowing that initially the mass was expressed in gram. So 1 AMU is equals to how much gram? So right, relation between AMU and gram. Means 1 AMU is how much gram? So this is very easy. If we have understand the definition of this AMU, we can quickly write this relation between AMU and gram. A student, just we have learned since 6.022 into 10 to the power 23 atom of carbon have how much mass? Can you tell me? Yes, student?
12 gram.
Very good. Have 12 gram. That we had written earlier. It simply means 6.022 into 10 to the power 23 carbon atoms is identical to 12 gram. Okay. So if we are taking the one carbon atom, then what become? Then one carbon atom mass, it is also the mass here. So one carbon atom mass is equals to how much? This much have to be brought into the denominator of this 12. Yes, student, any doubt? So bring it into the denominator of this. So it becomes 12 divided by, all this will come in denominator, 6.022 into 10 to the power 23. The unit is the gram, so gram have to be met. A student, you are knowing now, say 20 pencil cost 50 rupees, then one pencil cost how much rupees? 5 by 20, or say 50, then 50 by 20. The same thing we are using here. Say 6.022 into 10 to the power 23 carbon atom is 12 gram. So one carbon atom will how much gram? 12 divided by this. This will come in denominator. So we have to write forward. So one carbon atom mass is equals to 12 divided by 6.022 into 10 to the power 23, this much gram. Now, a student, this is the mass of one carbon atom. But what is AMU? AMU is even we have to take the 1/12 of this. So 1/12 of this gives AMU. This was the definition. Means you need to take one atom and you have to divide it by 12. Means 1 AMU is equals to how much? 1/12 of mass of one atom, mass of one carbon atom. So here we have understood mass of one carbon atom is this much. We have written in the right hand side. So we have to put 1/12 before that. So student, mark it. So it is our 12 divided by 6.022 into 10 to the power 23. This much gram. Here we are observing the 12 in denominator and 12 in numerator get cancelled. So it simply becomes 1 by 6.022 into 10 to the power 23. This become gram. So to solve this, you have to go for dividing it. So bring this denominator exponent into numerator. You may write 1 by 6.022 into 10 to the power minus of 23 gram. To divide this, so in numerator it is 1. We may write this as 10 by 6.022 into 10 to the power. Numerator, we have taken a 10. So it becomes minus of 24 gram. Okay, student? So go on dividing. It becomes 1.6 times into 10 to the power minus 24 gram. Therefore, what was this? This is our AMU. Therefore, 1 AMU is equals to approximately 1.6 into 10 to the power minus 24 gram. Unit is here gram. We can also express this in the term of kilogram. For kilogram, what we need to do? We further have to divide this by 1000. This much kilogram. Dividing in 1000 means it is 1.6 into 10 to the power minus 24 divided by, it is our 10 to the power 3 in denominator. So when it will go to the numerator, it become 1.6 into 10 to the power minus of 27, means 24 into 10 to the power minus 3. You may write this step also. So it becomes totally like this, 1.6, adding the same exponent because they have same base, minus 27 kg. So therefore, the point to be kept in mind, 1 AMU or 1 U is equals to 1.6 into 10 to the power minus 24. If you are taking minus of 24, you need to put the unit gram, or if you are taking 1.6 into 10 to the power minus 27, the unit will be kg. Yes. So this is what we need to keep in mind. So from here we can observe that the mass 1 AMU is very, very smaller than the gram. Are we getting? See, for the gram, the factor is 10 to the power minus 24. So 1 AMU is very, very smaller than the gram. It is this. So these are the things that we have learned today, and this I have to finish today. A student, please go through this video once more because it is entirely new thing for you people. So, but still, if any doubt persists, I will discuss more about this on next day. Otherwise, I may start with the new topic, because unless or until you understand this atomic mass, we cannot go ahead. We cannot understand any other topic of the chemistry. It is useful everywhere in this chapter, in our next chapter, as well as in our class 10th. Okay, student? So now I shall stop the class because the class have gone too longer. So this way we have defined the AMU. What is AMU? Definition of AMU is very important. So the definition that you have to keep in mind is this definition. So 1 AMU is 1/12 of mass of an atom of carbon 12. This is now acceptable, and this is the definition you have to write. Okay, you need not write the above definition or above in term of hydrogen and oxygen. They are obsoleted. They were used earlier, but now it is different. What is the relation between these two? It is also important. From this, we have concluded that this AMU is very, very small, because in gram it contains Avogadro number of atoms. That we have to keep in mind. This much atom were present, but for AMU we need only one atom. So we have taken one atom to get the AMU. Are we getting? So these were the things. So with this, let us stop the class here quickly, and you people please do the homework
Okay, sir.
of your book at your page number 35. All the blue questions you have to do. Okay, student? And please go through
Okay,
this
sir.
video once again. I will upload it by today itself. Okay,
Okay, sir.
students, I will stop the class here. We
Thank
are
you,
too
sir.
late.
Okay,
Okay.
sir.